Few weeks ago, I made a video on how you can combine lower time frame candles and create higher order candles. On that video, I received a comment to explain if it's possible to aggregate candles real time, as in get the live feed from a WebSocket and then aggregate those to a higher order candles. In this video, I'm going to explain how to do it. So we'll take the code that we used in that video and build something like this. So you can see when I change the time frame, you will see the higher order candles rendered, and you can see that it's live chart. You can see the price updated on the y-axis. Perfect. So let's look at how to build it. Before we begin, I recommend you to watch this video that I did a few years ago, where you can plot your own charts plot Tradingview charts with your own data using the lightweight charting library. And in this video, I talked about using a proxy in order to use a WebSocket. So in this video, I'm going to use Binance WebSockets to create the real-time aggregation. And again, because of how the Binance WebSocket API is designed, you cannot call those APIs directly from the browser. So you need to create a proxy server and then relay the data from the proxy server in order to make the WebSocket work. So again, I don't want to repeat that again in this video, so watch this one if you want to understand more about it. So in my project, I'm going to start with two folders. One of them is the proxy and the other one is the client. Client has the same code that we used in the last video, where I have a CSV file and all the other stuff. First, let's work on the proxy server. I'm going to initialize an empty Node.js project. Then I'm going to set the type to module because I'm going to use ES6 syntax. Then I'm going to install these 5 packages: CORS, Express to handle API, to create API routes, GOT to manage API calls, Socket.io to create WebSocket connections, and WebSocket packets to connect to the Binance WebSocket. Let's hit enter and install these. Awesome. So first I'm going to create proxy.js file. First, I'm going to create a simple Express server that runs on port 4000, and then I'm going to add a middleware, the CORS middleware, for these APIs to work on the browser. Then I'm going to import the GOT package in order to make the API calls, Binance API calls, and then I'm going to create a route called Proxy, which is where I'm going to handle the Binance API calls. Again, I need this proxy to be able to retrieve the last 1000 1-minute bars from the Binance API, so that I can use it in the aggregation. Okay, I need to combine the historical data and the real-time data so that we have enough data to render on the chart. Then I'm going to import symbol and interval as the parameters, and then query params, alright? And then I'm going to do a small validation that they're not empty, and then I'm going to have a try catch block where I'm going to make an API call to the Binance exchange and then get the candlestick data and then just return it, alright? And if there is an error, I'm going to send an error message. That's it. Let's run the proxy and see how this works. If I go to the server and open the proxy route, you can see that symbol and interval parameter was missing. When I pass the symbol and interval parameter, you can see that the data is rendered. So this is how we're going to use the proxy API. Now we need to create a WebSocket connection to the Binance server that emits 1-minute candles real time. Alright. I'm going to create a file called Binance WebSocket.js. Inside this module, first I'm going to import the WebSocket package, and then I'm going to create a class called Binance Kline WebSocket, and then I'm going to export by default. Then again, constructor, we just initialize the WebSocket variable. Then I'm going to create a connect method where we'll establish a connection to the Binance WebSocket, and I'm going to hardcode the symbol and 1-minute K lines. Again, this can be improved by making it dynamic, but to keep it simple, I'm going to just directly connect to the BTC USDT pair and 1-minute candles. Then I'm just going to handle all the other events like open, and when I get a message, I'm going to send it to this onKline method, which I'll create in a few seconds. Then I'm going to add the other event listeners on close and on error. Then I'm going to create this onKline method, which I'll handle when I create the socket.io connection. Let's save it. Then go to the proxy.js main file and then import socket.io and this Binance Kline WebSocket class. Alright. Then I'm going to create an IO connection using the Express server Just to avoid confusion, we use the WebSocket package to establish a WebSocket connection to the Binance API, and we use an socket IO connection to establish a real-time connection to the browser. All right, and we use this IO to send the real-time data from the proxy server to the browser. All right. Then I create the socket IO server, and then I'm going to initialize this an object using the Binance Kline WebSocket class, and then we're going to handle the on Kline method. So whenever we get a real-time data, we're just going to emit to this topic, Kline topic, and we're going to listen to this topic on the browser to accumulate the real-time data. All right. Then I'm going to call the connect method to establish the connection, and then whenever I receive a connection on the socket IO, I'm just going to have some logs that a new user got connected. That's it. So for now, let's console log the data and see how it looks. All right, let's start the proxy server. You can see that we are connected to the BTC USDT pair 1 minute K lines, and we are getting a real-time stream of the candlestick data. So one thing that I would do is format this data in the format that the lightweight charting library can consume. So we'll just go to the Binance WebSocket and create formatted data where we're going to capture the timestamp, open, high, low, close, volume, and then send it instead of the raw data. All right. And now if we start the proxy server, perfect. It looks much better, right? I'm going to stop the server, and we can also get rid of this console log statement. You can comment it out. That's it. Our proxy server is now ready. Let's move to the client-side code. I'm going to keep the proxy server running so that I don't have to look at it while I'm working on the client-side code. All right. I'll minimize this panel. So this is where we have the code that we used in that Kline aggregation video, where I have some candles in a CSV file and 1 minute candles in the CSV file, and we use that to create higher order candles. So first I'm going to change in the index.html file. I'm going to change the select option to have 2 minute as the default aggregation. And I also need a socket.io CDN to be able to establish connection to the proxy. So if I go to the CDN.js libraries, I can get a link to the socket.io package, and I'm going to import that script tag. One thing to keep in mind is if you go to proxy server, go to package.json, you can see that the socket.io version is 4.8. So make sure that the version that you're using is also 4.8 on your client side. Otherwise, you might have compatibility issues and the connection may not get established. We're going to refactor this code to facilitate real-time candlestick aggregation. All right. So first I'm going to get rid of this data.csv file because we're going to retrieve candles through an API. And in the index.js file, I'm going to change this getData function to get the data from the API, the proxy API, instead of the data.csv file. All right. So this is how it's going to look. We're going to pass the symbol as BTC USDT and interval 1 minute, get the candlestick data, and then format it in the way that the library can consume. All right, that's it. Then instead of putting all the code in index.js file, I want to create a separate file called kline.js, and we're going to create a class called kline where we will handle all the rendering logic so that the code looks cleaner and it's easy to read. All right. So I'm going to create a new file called kline.js, and I'm going to import it in the index.html file. Make sure you import this before the index.js file. So everything that we create here, the top one is automatically available in the index.js. Okay. So in the kline.js, first I'm going to move these three functions because, like I said, we'll handle all the rendering logic in the Kline file. So just move them here, and we'll keep the display chart as it is for now. First, we'll update the kline.js file. We'll create a class, and then we'll get back to the index.js file. All right, let's create the Kline class. So first, I'm going to create the Kline class. And then I'm going to create a constructor. I'm going to pass the ID of the div element where the chart is hosted. And in the constructor, I'm going to initialize all the defaults like chart properties, DOM element. I'm going to store all the 1 minute K lines because whenever the time frame is changed, I do need the historical data for aggregating again. So I'm going to store all the 1 minute candles, and the target K lines is where we'll have the aggregated K lines, and then the target time frame, which is null by default. And we'll also have a render last bar flag. Let's ignore that for now. Then I'm going to create a method called upsert 1 minute K line. So what it does is every time you add a K line, if it's already present in the array, it's going to update it. If not, it's going to append it towards the end. So if it's already existing, just upsert it. If it's not there, then insert it towards the end. All right, so let's do that. So I'll try to get the index based on timestamp, and if it's already existing, just update it. If not, just append it. All right. Then I'm going to create a method called set the target time frame, and here is where we're going to change the time frame. And whenever the time frame is modified, we'll just set it to the target time frame and run the render all method. So which is what we're going to create now. So in the render all method, again, if the chart is already initialized, we'll just remove the chart so that when the time frame is changed on the page, we just remove the existing chart and create a new chart. And we already did this in the last video. So just create the lightweight charts and create a candlestick series, set the margins to make them look beautiful, and create the volume series, and then create the target K lines based on the 1 minute K lines and the target time frame. And we already created this convert time frame function in the last video. All right. Again, then just after you convert the candles, just set the data to the candlestick series and also the volume series. That's it. So just hit save, and let's use this class to render the K lines. You can see that all the complexity is obfuscated into the kline.js file, so the index file is going to look much cleaner. All right. Now here we're going to have a function called main, which we're going to run on load. All right. So in the main function, again, we just get the Kline data using the getData method and initialize a new object, which is a chart, using the Kline class. And we're going to pass the ID of the DOM element where the chart is going to be hosted. And for each Kline data, we're going to call the upsert 1 minute Kline method we created. And then after we set all the historical data, we're going to establish a connection to the socket IO, and then listen to the Kline method. And every time we get a real-time candle, we are just going to upsert this data again to the class. All right. So the way this upsert method works is when we subscribe to the real-time data, we're going to get updates to the same candle repeatedly. So it's not going to create a new candle. Instead, it's just going to update the existing candle, which is what we want. All right. And finally, we're just going to call the display chart method. And the display chart method is also going to be a lot simpler. So we don't need all this functionality because it's already obfuscated into the class. So all we're going to do is set the target time frame of the chart in the display chart method. That's it. And finally, we're just going to call the main function. We don't need to call the display chart first. We need to call the main function. So whenever we reload this page, we'll just get the historical data, then set it to the class, then subscribe to the real-time data, and then display the chart. Again, the default is set to 2 minutes because we set it to 2 minutes on the home page, right? We said the default time frame is 2 minutes. So let's set it to 2 minutes, and that's it. So let's run this. We should see a historical aggregation. So if you go to the page and hit refresh, this looks good, right? So it is aggregated. You can see the timestamp below, 6:10, 6:12, 6:14, 6:16. So it is aggregating properly. If I change this to 5 minute, you can see 55, 6 o'clock, 6:05, and so on and so forth. So it does work well, but it's still static. It doesn't take real-time data into account. So let's go to the Kline class and create a new method called render last bar. So what this does is, every time we receive a new candlesticks, let's say we are aggregating on the 5 minute time frame, and let's say you receive a candle at 6:42. Okay. So what we'll do is we'll get the nearest normalized timestamp. So if you're doing a 5 minute candles, then 6:42, as in the candle should open at 6:40, right? So we take all the candles from 6:40 and above, and we use that to create the last bar, right? So we get the open timestamp, normalized open timestamp. So if it's 642, we get 640, and then we're going to slice, get the index of the last bar from the 1 minute candles, all right? The index of the 640 candle, all right? And then we're going to create a slice of the last few bars, whatever they are, all right? And then we're going to aggregate those candles to create the last bar. We'll create this aggregate candles function in a minute. And then using the last bar, we can just call the update method to update that particular bar, all right? We use that update method on the candlestick series and also on the volume series, all right? We'll just create the last volume bar and also update that on the volume series. Let's save it, and let's first create this aggregate k-lines function. It's going to be a really straightforward function. Just create the aggregate k-lines. We'll pass a array of candles and the target time frame. So the open timestamp of the candle is going to be the normalized timestamp of the first candle. Again, like I said, if you get a candle at 642, the open timestamp of the candle, if you're aggregating on the 5 minute, is going to be 640, all right? And then we get the open value. Open is always going to be the opening price of the first candle, and high is going to be the max of all the highs, and low is going to be the min of all the lows. And close, we did this again, right? We did this already in the convert time frame function. So close is going to be the closing price of the last bar, and then volume is just going to be a summation. And we use that to create the last bar and just return it, all right? And when do we need to call this method? So we need to call this method every time this upsert 1 minute k-line method is called. But there's a catch. So whenever the time frame is changed, we're going to render all the data, right? So while we're rendering all the data, if we receive a new real-time candle, we don't need to run it, right? So that's where we use the render last bar flag. So what we'll do is, whenever this render all method is running, we'll set it to false, and then once everything is finished, we'll set it to true, all right? So that way, while the historical bars are rendered, we know that we don't have to render the real-time bars, right? So, and then we go back to 1 minute candles, upsert 1 minute k-line method, and whenever this flag is true, we just render the last bar. That's it. We are already calling this upsert k-line method every time we receive real-time data in the k-line topic, right? So this is already taken care of. So the data is already fed to the object. Now we just need to render the chart. So which is what we did in the render last bar. Now if you go back to the page and hit refresh, you can see that it's working fine and it's real time. You can see the price on the y-axis price scale. You can see that it's changing real time. And yeah, you can change to a new time frame and it works. Just to show you that it's accurate, I'm going to have the Tradingview chart below and the one that we created above. And I'm going to run a time lapse for a while so that you can compare the values and see that it's accurate and it works just like Tradingview does. Perfect. So you can see that it's accurate and it works just like Tradingview. Alright, that's it for this video. As always, I'll leave a link to the code in the description box and you can get it from there for free. And I think there are definitely some improvements that can be done to the code. For example, the proxy Binance WebSocket, we could make the symbol and time frame dynamic instead of hard coding the values. So yeah, there is definitely, improvements that can be done to the code, but I want to keep this one simple and focus on the aggregation aspect. So as always, leave your thoughts and suggestions in the comment section and I'll talk to you in the next one. Bye.